Hi everybody, it's Mrs. Mancuso and I am continuing on with the January 2019 Regents exam. So make sure that you have it printed out and right in front of you so we can go through it together. This is video 2 of 4 and I'm going to go through part B1. So the first question, the three nuclides uranium-233, uranium-235, and uranium-238 are isotopes of uranium because they have the same number of protons and, all right, so the mass, 233. This is equal to protons plus neutrons. So if this one is different and this one is different, it's because they have a different number of neutrons. So there's our answer. Diamond and graphite have different properties because they have different, all right, so here's diamond and graphite, and they're both forms of carbon. So they're both the same element. So they're both gonna have the same electronegativity, they're both gonna have the same number of protons, and they're both gonna have the same number of valence. So what we're left with is different structure. And the fact that their structure is different is what gives them different properties. All right, given the equation represented below, this reaction is classified as, all right, I have a compound and a compound. Sodium ends up going with NO3 and silver ends up going with chlorine. So both of them have switched, so that is called double replacement reaction. What is the formula for iron 2 oxide? Iron 2 tells me to put a +2 on my iron. Oxygen, you can look it up if you're not sure. You look up the oxidation state in the top right corner. Oxygen is a -2. So when you crisscross, you get Fe2O2, but there's no reason to have a 2 and a 2. They cancel each other out. So you would have just FeO. Given the reaction, how many moles of KCl must completely react to produce 6 moles of oxygen? So there's 2 ways to do this problem. The first way is to think of this as a recipe, and my normal recipe makes 3 oxygens. If I wanted to change that to 6, I would have to double everything in the reaction. So if I want to know how many KClO3s, I normally have 2, I would need 4. So it's as easy as doing that. Or if you like doing out as dimensional analysis, you would write 6 O2s, O2s on the bottom. I want to know how many KClO3s, and you do a mole to mole comparison. So my normal reaction has 3 here and it has 2 here. 6 times 2 is 12, divided by 3 is equal to 4. So you come out with the same answer and you can solve it either way. What is the number of moles of CO2 in a 220 gram sample of carbon dioxide? And this is so nice. They give us the gram formula mass of carbon dioxide. So if I want to find the number of moles, you can go to table T. Most of your calculations are on here. Number of moles is equal to given mass over gram formula mass. So they gave me 220 and I want to divide it by 44 and that will tell me how many moles. So I grab my calculator, 220 divided by 44 is equal to 5 moles. The next one, a solution contains 25 grams of KNO3 dissolved in 200 grams of water. Which numerical setup can be used to calculate the percent by mass in the solution? All right, so here's my beaker. I have 200 grams of water and I'm adding 25 grams of KNO3 to it. So to do percent composition, again, I can look on table T, I want the mass of the part over the mass of the whole. So the part that I added in is 25, and my whole is these two together, so 225. And then to do a percent composition, I have to multiply it by 100. So I want 25, there it is, over 225 times 100. Please don't be tricked by this one. This is part over part times 100. You want to make sure you have part over whole times 100. What is the molarity of 0.5 liters of an aqueous solution that contains 0.2 moles of NaOH? And it gives me the gram formula mass. I actually don't need the gram formula mass, so I guess they were trying to trick me, but I will not be tricked. So I go here to molarity. Molarity is moles of solute over liters of solution. So they gave me 0.2 moles, and they gave me 0.5 liters. So when you divide 0.2 divided by 0.5, you get 0.4. So the molarity would be 0.4 m. A mixture consists of ethanol and water. Some properties of ethanol and water are given in the table below. Which statement describes a property of ethanol after being separated from the mixture? So I want to make sure that I find something that matches its original property, because mixtures, they still maintain their own properties. So ethanol is non-flammable. Ethanol is flammable, so that's not true. Ethanol has a melting point of 0. Ethanol's melting point is not 0. Ethanol has a density of 0.8. Ethanol, yes, it does have a density of 0.8. And I could look at this last one just to make sure. Ethanol has a boiling point of 89. So boiling point is 78, not 89. So it was really just reading the chart. A rigid cylinder with a movable piston contains a sample of hydrogen gas. At 330 K, this sample has a pressure of 150 kilopascals and a volume of 3.5 liters. What is the volume of the sample at STP? All right, so what I need to do is I need to set up my P1 V1 over T1 equals P2 V2 over T2. So that's right here from the back, my gas law formula. All right, so I'm going to take what I am given. 330 K is my first temperature. It has a pressure of 150 and a volume of 3.50. So those are all my initials. And then at STP, I got to find the volume. So V2 is what I don't know. At standard pressure, my standard pressure and my standard temperature are right here. It used kilopascals, so I have to use kilopascals. So I want 101.3 and I want 273. All right, and now to solve it, I cross multiply. So I'm going to multiply 150 times 3.50 times 273. I get 143,325. So that's going to be my top number. And then on the bottom, I have 330 times 101.3. I get 33429. I now divide 143,325 divided by 33429, and I get 4.287. So 4.29, there is my answer. Which numerical setup can be used to calculate the heat energy required to completely melt 100 grams of water at 0 degrees? All right, so as soon as I see heat and melting, I know I want a Q formula. So I go to my equations over here, and the melting one is called fusion. So I want Q equals MHF. And so here, I'll do it on my scrap paper. Q equals MHF. So the mass is 100 grams. HF, I get over here on my reference tables. Heat of fusion is 334. So when I multiply, I would get 33400 joules. Oh, I didn't even have to do that. I just had to show the numerical setup. So I want 100 times 334. All right, next one. During which phase change does the entropy increase? So entropy is the amount of disorder that a system has. So if I go from a gas to a liquid, I'm actually becoming more organized. So I don't want that. Gas to a solid is way more organized. Liquid to a gas, there we go. Liquid to a gas, my liquid, my molecules would be like this, but a gas, they would be much more spread out and disorderly. This one, liquid to solid, is decreasing in entropy. What is a chemical name for this compound? So I notice right away that it has a functional group. So I circle it and I go find it. I go to table R and I find N with 2 H's. There it is. Here's N. So I know that I want an amine. It does not have a carbon with a double bonded O, so this is my nitrogen choice. I notice that there is a number to show where the nitrogen functional group is. There's prop to show me this one had 3 carbons, and the ending is anamine. So anamine, these both say anamide, so I don't want that. These say anamine. And now I have to choose which number. Well, I always want to count closest to the action. So here's my action. So this is carbon 1, 2, 3, 4. So I want to choose 1 butanamine. But because it has 4 carbons, 1 because the functional group comes off of the first carbon. All right, which type of reaction is represented by the equation? So this is an organic reaction because I'm starting with butane and I'm adding chlorine, and I switch out one of the chlorines of my Cl2 for one of the hydrogens. So when I just switch one, that is called substitution. It is not addition, because addition, I would have to start with an alkene, and an alkene would be C4H8. So let me just show you what I mean by that. Here are my alkenes, and here's my formula. I can always look at the formula and compare the N's to the H's and figure out if there's a double bond. Addition involves a double bond, and you break it and add it together, and so you just have one product. This had 2 products, so it was just a substitution. Which half reaction represents reduction? So I have this saying, oil rig. The rig goes down into the earth and the oil comes up out of the ground. And this is what everything stands for. Oxidation is losing electrons, and my oxidation number increases. Reduction is gaining electrons, so if you gain negatives, your oxidation number goes down. So I want to find something that is gaining electrons and the oxidation number goes down. So the first one is not gaining. The second one is gaining. I'm going from a +2 down to a 0, so this is reduction. The next one, if I take Ag and I add an electron, I should come out at -1, so this one isn't even balanced, and the next one does not gain an electron. All right, given the balanced ion equation, which statement describes the electrons involved? So I can look at this right away and already know that it's redox. My Zn is going from a 0 to a +2, so this is oxidized. And this one's going from a +2 down to a 0, so this one is being reduced. So each Zn is going to lose 2 electrons, and each CO +2 is going to gain 2 electrons? Yes. I want the number of electrons to be equal. This one is losing 2, this one is gaining 2. What are the 2 oxidation states of nitrogen in NH4NO2? All right, so let me grab a piece of paper. NH4NO2. So I want to know what state this is and what state this is. So hydrogen's a +1 and oxygen is a -2. This gives me a 4 and this gives me a -4. I know that all of these added together has to come out to 0. So if my +4 and my -4 cancel out, these 2 numbers have to also come out to 0. So if I have a 3 and a 5, that is not going to come out to 0. A 3 and a -5 is not going to come out to 0. This is +3 and -3 does work out. And that would be my answer. -3 and -3 would not come out to 0. The table below shows the molar concentration of hydronium ion H3O+ in 4 different solutions. So first of all, H3O+ is what you get if you add an H+ to water. And an H+ is what an acid donates. So I know that I'm talking about the acid concentration when I'm talking about H3O+. The more it has, so this one has the highest and this one has the lowest. So this one is going to be my most acidic, and this is going to be my weakest acid. So the question is, which one's going to have the highest pH? Well, the pH scale goes from 0 to 14. Here is the greatest acid. Here is the greatest base, highest pH, I'm going this way towards a base, so I want to pick the one that is the weakest acid. So I want to pick D. All right, what type of nuclear reaction is represented by the equation? First of all, I know it's nuclear because they took the time to write out the mass and the charge of everything involved. So it is definitely involving the nucleus. And I took uranium, which is a huge nucleus. I fired a neutron at it, so it's definitely artificial transmutation. That's not a choice though. So I have to look at what happened. Uranium split into barium and krypton and 3 neutrons, and it gave me a lot of energy. So decay is a natural transmutation where there would not be a neutron before the arrow. There would simply be uranium, and there would be an alpha after it or a beta after it. This is splitting. Fusion is combining. Fission is splitting, so I want to pick fission. Which nuclear emission has the least penetrating power and the greatest ionizing ability? So the least penetrating power is definitely an alpha. So an alpha, it's not very penetrating. You can stop it very easily. You can stop it with a piece of paper. So that has the least penetrating power. All right, so join me in the next video for part B2.